This design project for Structures 2 was one of the most interesting projects we've done throughout the program. The project compromises of designing the structural members and connections for a domestic shed, as well as to investigate and to design overall building stability under a certain amount of wind load, live load and dead load. The final shed was to be economical and safe. Therefore, a large amount of calculations were completed throughout the body of the report. Two key components are load types, the types of loads that are applied to the shed, and connections. The connections that transfer and support these loads. Together, we use both the components to start the basic design of the shed. In construction of steel systems, there are usually two types of connections, bolted and welded. Bolted or welded connections are quite often used in the construction of steel systems. These connections are generally designed to have precise rigidity. These connections are all designed in different but unique ways to support the loads for the domestic shed. The type of support that is utilized indicates the heat that can be upheld or resisted and decides the load bearing limit of every member. Acting upon this are three different load types. The ones commonly used in construction are roller, fixed, and pin supports. Roller supports. As there is horizontal force applied to bridges, the roller support will move across the surface without resisting the applied horizontal force. Roller supports are unable to provide resistance to lateral forces, which is an issue as most structures are subjected to lateral loads. For this reason, a building must have another type of support in addition to the roller connection. The roller support will move across the surface without resisting the applied horizontal force, as horizontal force is applied to bridges. Roller supports cannot provide lateral force resistance, which is a problem as most structures are subjected to lateral load. For this reason, apart from the roller connection, a building must have another type of support. Pin supports. A pin connection just opposes vertically and horizontally. However, it is subject to moment. This will enable structural members to pivot, however, will stop some other directional movement. Pin connections can likewise oppose little measures of moment as long as the moment is less than the limit of the connection or support. Pin supports are commonly utilized at the base for joining columns/sections, as these members are fundamental pieces of a structure and should limit any directional loads. Fixed supports. Fixed supports compel a member to form a rigid connection in all directions, including rotational movement. A fixed connection does not offer anything inside a structure, so it is not always necessary to choose a fixed support because it may not meet the structure's needs. Other types of support systems in construction consist of rafters, columns, bracing, and purlins. A rafter is a structural component that is used as part of a roof construction. It's a type of beam which tends to hold up the main structure of a building load and creates a roof's framework. A column is a vertical structural member that carry loads mainly in compression. It is assumed to be the most crucial structural member of a building because the safety of a building rests on the column strength. It might transfer loads from a ceiling, floor slab, roof slab, or from a beam to a floor or foundations. A purlin is a horizontal beam along the length of a roof, resting on principals and supporting the common rafters or boards. Structural load types in construction are dead load, live load, and wind loads. The dead load of a structure is continuous through the life of a structure. The roof of a structure is considered as part of the dead load also. The components that make up the dead load of a structure is the weight of the structure itself, which includes fixtures. walls, cupboards, and plasterboards, and also floor surfacing materials. Everything, including materials inside a building, are only considered a part of the dead load when they are fixed into a permanent position, as mentioned above. The dead load of a building can be exactly calculated from the known weights and dimensions of the materials used in the structure. A structure's live load is the accumulation of all moving objects within the structure. Live loads vary from structure to structure and depend on structure usage. For example, live loads on the roof and floor are produced during maintenance by workers and their equipment, while live loads on the bridge are produced by cars driving over the bridge deck. The wind load affecting a structure has become a major factor to consider due to the widespread use of lighter materials and time-efficient construction techniques in present and future construction. The strength and serviceability of a structure is affected by wind load as it affects both the structure itself and the exterior cladding. The structure, in this case a shed, must be strong enough to resist the horizontal load, and there must be sufficient anchorage to prevent the shed from blowing away if the dead load is not adequate to hold it down. Thank you for watching.